the mathematics of finance. Okay? So far in the investment situations we've talked about, the investor has made a single lump sum deposit. So they start out and say, I'm going to invest $1,000 and just let it sit there. Never do anything again. Just let it sit there. But more realistically, investors make regular deposits. Okay? Most of the time they'll do this monthly. Every month, out of their paycheck, they set aside so much that they think they need to save. So they're saving basically the same amount every single time. So every single month they're saving maybe $100 or $150. This is called an annuity situation. Okay? It's called an annuity. An annuity is a sequence of equal periodic payments. There are two formulas that we're looking at. The first one is called future value, FV. The future value of an annuity consists of T equal periodic payments of R dollars at an interest rate divided by the compounding period. This is the formula. Future value equals R, your monthly payment, times in brackets. In the numerator, it's 1 plus I, where I represents the rate divided by the number of compounds, raised to the power of n times t, minus 1 divided by I. Future value is when you say, I am going to put $100 into this savings account every single month for the next 10 years. How much will I have in that 10 years? So in the future, what will the value be? That's future value. Present value, PV, of an annuity consists of T equal payments of R dollars and an interest rate I per period. Present value, the formula is a little bit different. It equals R, the monthly payment, times in brackets in the numerator 1 minus, in parentheses, the quantity 1 plus I, raised to the power of negative n times t. So you need to note that the power is negative. It's a negative exponent. And that's divided by I. Present value is used for taking out mortgages or an automobile loan or a school loan, anything like that. When you're taking out a loan, you're dealing with a present value situation. When you go to buy a car, today's price of the car might be $25,000. That is a present value for the car. This formula we can use to calculate what the monthly payment would be. Okay? How much are you going to pay every month for that $25,000 car? So let's look at example 1. Suppose Kanye West wants to invest some of his pennies for North, South, East, West. New child. So the new child's name is North, South, East with the last name of West. Okay? So in situation A, we have two situations. In situation A, he invests a one-time lump sum of $1,000, compounded monthly at 8% annual interest. How much will he have after 20 years? Okay, so is that using one of these formulas? No, it's using the formula that we just learned, okay, of compounding interest. So the compounding interest formula, A equals his initial amount, the lump sum of 1,000, times 1 plus his rate of 0.08, divided by its compounded monthly, so that's 12, raised to the power of 12 times 20. All right, use your calculator and calculate that value. All right, so what is that amount? $4,926.80. Now in situation B, this time he invests $100 each month, compounded monthly, at an 8% annual interest rate. How much will he have in 20 years? This time, I'm doing a fixed amount every single month for the next 20 years. That's $100. So do I want to use the present value formula or the future value formula? Future value. I'm doing $100 every month. How much will it grow to in the future in 20 years? So future value. All right, so future value equals $100 a month, that's the capital R, times in the brackets. We have a fraction, so in the numerator it is 1 plus I, and I is the rate, 0.08 divided by number of times compounded, 12, raised to the power of 12 times 20 years. At the end of it, there's a minus 1. And that's divided by I, which was the rate, divided by number of times compounded. Now, let me tell you right now, if you don't use the fraction feature on the calculator, the alpha y equals, very slim chance that you can type this into the calculator correctly with a whole bunch of parentheses. So don't risk it. Don't risk it. So let me pull up my calculator. Okay. So again, on the calculator, use the fractions so that you can make the calculator look exactly like what's on your paper. That's the only way you can guarantee you'll get the correct answer. So our correct answer is $58,902.04. All right. Now, let's compare these. We need to determine the amount he paid out in each situation and compare it to his return. So in situation A, how much did he totally pay out? He paid $1,000. So we're going to subtract $1,000 from that. So 4926.80 minus 1,000. So he actually had a return of $3,926.80. Now let's figure out, that's versus situation B. We need to know how much in total he paid out in situation B. Okay, so he put in $100 every month for how long? 20 years. So $100 times 12 months for 1 year times 20 years equals $24,000. That's how much he paid out. But how much did he get in return? So the future value, $58,902.04 minus the $24,000 he paid out. So his net return was $34,902.04. So you can earn a lot more interest if you are putting in a lump or a sum, a payment every single month. Okay? You can get a nice amount of money in the end in interest. Okay? All right. Let's flip it over. On the back, I just put the formulas up there again, so you don't have to flip over to the front. And then I actually changed the problem from what is actually printed on your notes. So I changed Pratt's to Bird, and I actually changed a couple of the numbers. So the Bird Investment Club is investing $125 each month, compounded monthly at roughly 9% annual interest for their daughter's college savings. Okay, so change up the numbers. It's $125. Compounded monthly 9% interest. Now, we've been doing this every month since the birth of our daughter. What will be the value of this annuity at the end of 18 years? Will there be enough money there to send my daughter to college? What do you think? Oh, yeah. Yeah, we have to make sure that we have money when she goes to college. So, are we going to have enough? Just give me a guess. Will we? $125 every single month. Okay, let's see.
Yes. No.
Is this present value or future value? Future value. Equals $125 every month times, in the numerator, 1 plus the rate of 0.09 divided by 12 raised to the power of 12 times 18 for 18 years, minus 1 divided by 0.09 divided by 12. All right, so in the calculator, 125, parentheses, fraction. In the numerator, parentheses, 1 plus a fraction, 0.09 divided by 12, close parentheses, raised to the power of 12 times 18. On the same line in the numerator, minus 1. In the denominator, we need the fraction, 0.09 over 12, close parentheses, and
C for
$67,043.96. All right. So, do you know how much college costs right now? Depends on which college. So let's say it's either UT or A&M or Tech. One of those three. Do you know how much that is about a year? Tuition, room and board, books, everything?
probably about that.
About 20,000, give or take. Might be 19, might be 21, but it's right around 20,000. So for 4 years, we need 80,000. And that's just the bare expenses. Tuition, room and board, books. So you come up short. And that is expecting a 9% annual interest rate. That's a lot. Is that realistic? No. What is realistic? A whole lot less, okay? Now, I'm going to pull up here in a second actual interest rates that are being offered at the bank right now. But when you invest in things like index funds, you can get a better rate, okay? So more realistic might be about 4 or 5% on something like investing in an index fund. Let me go ahead and show you an interest rate. So if you just put your money into the bank, you open up a checking account, you put it in the bank, and you say, all right, I want the bank just to hold my money and I want it to grow. So here we go. Current bank interest rates. How about Bank of America? I think everybody's heard of Bank of America. Are we familiar with that? All right, here we go. You ready for this? All right, guys, there it is. 0.03%. So, if you stick your money in the bank right now at Bank of America, the interest rate you are getting is less than 1%. It is less than half of 1%.
It is only 0.03%. So that is 0.0003. Yeah. Okay. So, there's a couple of other things. An IRA, but once you put money into an IRA, that's a retirement account. You can't touch it until you're old. That grows at 0.08%. Woo! And then there are CDs. Okay, a CD is a certificate of deposit. With that, you go to the bank and you say, okay, here's so much money. I'm putting it into a CD and I'm going to let it sit there for X period of time. So based off of the period of time determines your interest rate. So if you let it sit there for 120 months, your interest rate is 0.15%. Much better than 0.03%, but an interest rate of 0.15%. Now, how long is 120 months? How long?
10 years.
10 years. 10 years. Okay?
Is that annually or?
So,
What is the rate?
APY is an annual percentage yield. All right, so there you go. Yeah, you don't put your money in a bank to get your money to grow. That's not the place to put it. Now, stock market, that's too volatile. That is way too much risk. So then, once you get into economics, you should start learning about different ways that you can invest your money. A good way is like an index fund. Okay? Or there's lots of different funds out there that grow at a more decent interest rate, 4 or 5%. Kind of thing. Okay? All right. Let's try using the other formula. Example 3. Sam obtains a 30-year, $200,000 house loan with an annual percentage rate of 4.75% from Bank of McKinney. What is her monthly payment? All right, so we're going out and we're buying a house. The house costs $200,000 today. The bank says, okay, I'll give you a loan, but the interest rate is 4.75%. With that, we have to be able to calculate how much we're paying on this house every single month. What is our monthly payment? So, because $200,000 is a value today, we're using present value. Okay, so we're using the present value formula. The $200,000 is the present value. So 200,000 equals capital R, the monthly payment, times, in the bracket, in the numerator, we have 1 minus 1 plus I, which is the rate, 0.0475, divided by 12, because it's monthly, raised to the power of 12, or negative, excuse me. The exponent on the PV formula is negative 12 times 30, because we're taking out a 30-year loan. And that's divided by I, 0.0475, divided by 12. So the first thing we need to do is whatever's in the brackets here, we need to type that value into the calculator. All right, so I need a fraction. And in the numerator of the fraction, 1 minus, parentheses, 1 plus, I need a fraction, 0.0475 over 12, close parentheses, and that is raised to the negative exponent. Make sure for the negative that you select the negative, which is under the 3. Don't select the minus sign. That won't work. Negative 12 times 30. In the denominator, we need a fraction, 0.0475 over 12. Okay. Now, that's only on the other side that's multiplied times R. And I have that set equal to 200,000. So to solve for R, I need to take 200,000 divided by that number. So 200,000 divided by that number we just found. Enter.
That's per month.
That's per month. Okay, it's a dollar amount, so round to the nearest hundredth. The 191.7, take that all the way. You don't want to round that one. So that is $1,043.29. That's the monthly payment for a $200,000 house. Yes, that is a lot of money. Okay. Now, find the amount she paid in interest by comparing the amount she paid out over the life of the loan with the amount of the original loan. So if she's paying $1,043.29 every month for 30 years, let's calculate how much in total that actually is. So 1,043.29 times 12 months, so every single month, times 30 for the next 30 years, gives us a grand total of $375,584.40. So the loan amount was $200,000, but the interest she's being charged, 4.75% for 30 years, means in total, at the end of 30 years, she has paid $375,584.40. How much of that is interest? Subtract out what the loan amount was for, and that's $175,584.40 in interest. That's a lot. That is a lot. Correct. That is exactly right. Okay. Questions? Now, taking it a step further, she calculated this and she was like, oh my gosh, that is a ton of money in interest. What can I do to not have to pay that much in interest? Yeah, that's impossible. Nice try. Instead, what you can do is, even though the monthly payment is $1,043.29, each month you can pay extra. The extra you pay goes directly towards the principal amount of the original loan. So that's what a lot of people will do so that they can pay off their house quicker, okay, and avoid paying as much in interest. So let's say she just is able to put $100 more per month towards her house payment. So instead of paying $1,043.29, she's paying $1,143.29. Okay, so the loan amount is still $200,000, but she's going to pay $1,143.29 each month. That's R. Times 1 minus 1 plus 0.0475 divided by 12 raised to the negative 12 times t power, because t, we're going to figure out how much time is it going to, will it take her to pay off this loan if she pays $100 more, divided by 0.0475 divided by 12. Okay, PEMDAS. PEMDAS is going to help you out a lot with this one, okay, as we're trying to solve for t. First thing we need to do is divide both sides by 1143.29. So 200,000 divided by 1143.29. Enter. So 174.9337438 equals everything in the brackets. Now, if we look at the brackets, do we want this fraction in the denominator? No. So we can multiply both sides by that denominator. So on the calculator, this number 174, we multiply it times 0.0475 over 12 to get that whole entire fraction out of the denominator. Move it to the other side. Okay, are you with me so far? So this has been multiplied on both sides to get it out of the denominator. So now we're left with this numerator. What's the next thing in the numerator that should get moved?
Distribution.
No, the 1. The 1 first. So how do I move the 1 to the other side? Subtract 1. Okay, so from that, minus 1. So now we're here, right? Okay, let's go back. Now I have that negative sign. Well, I cannot distribute the negative sign because that parentheses has the exponent first. So how can I move the negative sign to the other side? Divide by a negative 1. So divided by negative 1. So now I have that 0.30755 number is equal to this parentheses raised to the power, correct? All right, so the 0.307, we're going to plug that into y1, and we're going to plug the parentheses to the negative 12t power into y2, and we're going to find the point of intersection. The whole thing. The whole thing. So 0.3075539.306. And then in y2, we're going to type in the parentheses of 1 plus the fraction 0.0475 over 12, close parentheses, raised to the power of negative 12t. Graph. Okay, so we can basically see our point of intersection. It's happening somewhere in here, correct? So, second, calculate, intersect, number 5, enter, enter, enter. The intersection point is 24.872. So instead of paying off the loan in the full 30 years, how much time has she saved? Okay, so time saved would be 30 minus 24.872, and that is 5.128 years was cut off the loan. Now let's see how much did she actually save in interest. How much did she save in interest? So let's see where I can find room. Let's just write it down here, or find a little bit of room maybe off to the side. This time, how much did she pay every month? She paid $1143.29. She paid that for every month, 12 months, but how many years did it take her? 24.872. So calculate that, 1143.29 times 12 times 24,872. and that is 341,230.91. So she cut 5.128 years off of the loan, and then she saved, well, she was at 375,584.40 minus 341,230.91. She saved $34,353.49 in interest. That's how much she saved. So do you think that's worth it? Yes. Yes, that would be worth it. Okay. Questions? Very good.